Hello, my name is Adam and I'm going to give you an introduction to NLP. Natural language processing is the ability of a computer program to understand human language as it is spoken in a subfield of artificial intelligence. Now, before understanding NLP, have you ever wondered, how does a child learn a language? If you observe carefully, initially they start responding to sounds, then they learn to say words, and finally, they frame sentences. Machines are no different. Language is a medium to interpret information, and us humans interpret this by strings of text by assessing at three different levels. Syntactic level. If the sentence is syntactically correct, it means that the grammatical arrangement of words in the very sentence is correct. Semantic level. It's the branch of linguistics concerned with meaning and the analysis of word meanings and relations between them. Pragmatic level. A branch of linguistics that deals with the relation between signs or linguistic expressions and their users. SPM is an example of supervised learning. This sentence is correct at all syntactic, semantic and pragmatic level. A rock smelled the color 9. This sentence is syntactically correct but semantically incorrect. The syntax of the sentence works just fine, but the sentence has absolutely no meaning because rocks do not smell, and, even if they could, they couldn't smell a color that doesn't exist. The author rejects the weather for it is his father. This sentence is syntactically and semantically correct but pragmatically incorrect. Believe can I hardly. This sentence is incorrect at all syntactic, semantic and pragmatic level. History of NLP. Computer scientists have been trying to create this automatic system to understand the language from the past 6 decades now. Initially, the models were trained based on the rule-based systems thanks to machine learning algorithms and big data, which have made the task of NLP possible. Steps involved in NLP are as follows. Sentence segmentation. Tokenization. Parts of speech. Text lemmatization. Stop words. Named entity recognition. Now let's understand these steps with an example. Consider a piece of text. London is the capital and most populous city of England in the United Kingdom. Standing on the River Thames in the southeast of the island of Great Britain, London has been a major settlement for 2 millennia. It was founded by the Romans, who named it Londinium. Now the first step which we're going to perform is sentence segmentation. In this, our aim is to break the text apart into separate sentences. After performing sentence segmentation, we get this. Step 2 is tokenization. Now that we've split our document into sentences, we can process them one at a time. Let's start with the first sentence from our document, which is, London is the capital and most populous city of England in the United Kingdom. After tokenization, we will get this. In the same way, the other 2 sentences can also be processed. Step 3 is parts of speech. In this, we'll look at each token and try to guess its part of speech, whether it is a noun, a verb, an adjective and so on. Knowing the role of each word in the sentence will help us start to figure out what the sentence is talking about. After processing the whole sentence, we'll have a result like this. As we can see clearly, London corresponds to a noun, it corresponds to the verb, it corresponds to the determiner and so on. Now that we've performed pause, next step is text lemmatization. In English, and most languages, words appear in different forms. Look at these 2 sentences. For example, there's a buffalo grazing in the field. There are buffaloes grazing in the field. Both sentences talk about the noun buffalo, but they are using different inflections. When working with text in a computer, it is helpful to know the base form of each word so that you know that both sentences are talking about the same concept. Step 5 is identifying stop words. There are various words in the English language that are used very frequently, like a, and, the, etc. These words make a lot of noise while doing statistical analysis. We can take these words out, they will be filtered out while doing some statistical analysis. Is, the, and, most are the stop words in the given sentence which are going to make no difference. Step 6 is named entity recognition. The goal of named entity recognition is to detect and label these nouns with the real-world concepts that they represent. Here's what our sentence looks like after running each token through our neurotagging model. In this sentence, London, England, In the United Kingdom, all correspond to a geographic entity. Now let's discuss the applications of NLP. Speech recognition. Speech recognition is the ability of a machine or program to identify words and phrases in spoken language and convert them to a machine-readable format. For example, without natural language processing, Amazon's Alexa would not be able to respond to your voice commands appropriately. Chatbots. Like the previous example with Amazon's Alexa, chatbots would be able to provide little to no value without natural language processing. Natural language processing is what allows chatbots to understand your messages and respond appropriately. When you send a message with hello, it is the NLP that lets the chatbot know that you've posted a standard greeting, which in turn allows the chatbot to leverage its AI capabilities to come up with a fitting response. In this case, the chatbot will likely respond with a returned greeting. Machine translation is an automated translation. It is a process by which computer software is used to translate a text from one natural language, such as English, to another, such as Spanish. For example, Google Translate. Sentiment analysis uses data mining processes and techniques to extract and capture data for analysis in order to discern the subjective opinion of a document. A very famous application of this is sentiment analysis of Twitter data. The objective of this task is to detect hate speech in tweets. A tweet contains a hate speech if it has a racist or sexist sentiment associated with it. So this was the introduction video to natural language processing. For more insights into the topic, stay tuned.